Derivatives of logarithmic functions and exponential functions. Up to now, we are dealing with derivatives of polynomial functions and rational functions. In this video, we present the formulas for finding the derivative of the exponential function and the logarithmic function. Before getting started, review the exponential and logarithmic functions by watching the videos that appear in the upper right corner. Thanks in advance for watching this video. If you like this video, don't forget to like and subscribe to the channel and activate the bell. It is very important for the continuity of this channel. We begin our discussion of the derivative of the exponential function by considering the following function. Let's now investigate this function. Note that as x increases or decreases indefinitely, the function takes on values closer and closer to a specific number. Look at the tables and the graph. This special irrational number we are found out is named e to represent it in honor of Leonhard Euler, the great Swiss mathematician who did groundbreaking work with it. It seems reasonable to assume that the limit of f as x increases or decreases indefinitely is this specific number. We can write this limit in another form that will be useful later. We make the substitution, and we can see that as x increases or decreases indefinitely, t approaches 0. Therefore, these two limits give the same answer. Now let's evaluate another important limit. We make the substitution, and we can see that as x approaches 0, y approaches 0 as well. We use the natural logarithms and we make algebraic manipulations to solve for x. We rewrite the limit as follows. We can use the limit above to show that this last limit is equal to the natural logarithm of a. We now are ready to find out the derivative of exponential and logarithmic functions. Now we consider the logarithmic function with an arbitrary base a. Let's find the derivative using the first principles. According to the definition of the derivative, we have the difference of the logarithmic terms can be combined by using the quotient rule of logarithms. We make the substitution, and we can see that as h approaches 0, alpha approaches infinite. We now use the limit on the side together with the change of base formula for logarithms. The derivative of the logarithmic function with arbitrary base a is simply 1 divided by x times the natural logarithm of a. If a equals e, we obtain the natural logarithm, the derivative of which is expressed by the formula. Let f of x equals logarithm of x base a, where a is a positive number not equal to 1. The derivative of f is given as follows. In particular, if you take a equals e, then the derivative of the natural logarithmic function is given as follows. Let's consider finding the derivative of the exponential function using the definition of a derivative. The factor a to the power of x does not depend on h, so we can take it in front of the limit. And by using the limit on the side, we obtain the derivative of the exponential function. Let f of x equals a to the power of x, where a is positive and not equal to 1. Then the derivative is equal to the original exponential function multiplied by the natural log of the base. In particular, if we take a equals e, then the natural log of the base can be reduced to the value of 1. This would simplify the derivative to the original function itself. In other words, if the base of the exponential function is equal to Euler's number, the derivative is equal to the original function. Find the derivatives of the following functions. To solve item A and B, we differentiate directly by using the formula for derivatives of logarithmic functions. To solve items C and D, we differentiate directly by using the formula for derivatives of exponential functions. We now use the chain rule along with the formula for derivatives of logarithmic functions. We now use the chain rule along with the formula for derivatives of exponential functions. We now use the product rule, then we use the chain rule along with the formula for derivatives of exponential and logarithmic functions.